Welcome to part 1 of our series on production-grade BDD. Today, we are going to establish the foundation of our application, setting the stage for some really robust, behavior-driven tests. So let's get started.
So, here's what we're going to cover. We'll kick things off by talking about the core philosophy of BDD. Then, we'll dive into a really key architectural decision, why we're separating our application and test code. After that, we're going to get hands-on, setting up our project dependencies, building the application skeleton, and finally, creating the data layer. Before we even think about writing a single line of code, it's absolutely crucial to understand the philosophy behind it all. Why do we even choose behavior-driven development for a professional-grade project in the first place?
Well, at its heart, BDD is really a collaboration tool. It's all about making sure everyone, from the product managers to the developers, is completely on the same page. We do this by using a shared, human-readable language. So instead of thinking in abstract test cases, we describe software behavior from a user's point of view. For example, given a user is logged in, when they add an item to their cart, then the cart total should update. That clarity, that's the real core of BDD.
Okay, now that we understand the what, let's get into the how. A crucial first step in any production-grade setup is thinking about our project structure.
So, this is a question I get asked a lot. Why not just toss the tests into the same repository as the application code? I mean, it might seem easier at first glance, right? But separating them, well, that gives us some really powerful advantages down the road.
This separation provides 4 key strategic benefits. First off, it keeps our application repository clean and focused strictly on production code. No test code cluttering things up. Second, it decouples our deployment pipelines. This is huge. It means our CI/CD system can run tests on a completely separate schedule, like a big regression run overnight, without triggering a new application build every single time. Third, it enforces good security practices. By externalizing configs, we make sure sensitive keys are never, ever hard-coded. And finally, it just gives us a really nice, natural way to organize different layers of tests, from API all the way to end-to-end.
All right, enough theory. Let's get our hands dirty and start building. We'll begin with the foundation of any Maven project, the POM XML file. This is what defines all of our project's dependencies.
And here it is. This is the complete POM XML for our little Spring Boot application. Think of it as the project's blueprint. It sets up our Java version and brings in all the necessary libraries we're going to need to get our web app off the ground. Now let's break down the most important parts. Let's look at the key choices we've made here. We've pulled in Spring Boot Starter Web so we can build our REST APIs. For the data layer, we're using Spring Boot Starter Data JPA, which gives us super simple and powerful database integration. We're also using the H2 database. Now this is important. It's an in-memory database that is absolutely perfect for development and testing because it requires zero external setup. And finally, my favorite, Lombok. This is an amazing utility that drastically reduces boilerplate code like getters and setters, which keeps our code so much cleaner and more readable.
Okay, with our dependencies all lined up, we can now build the actual skeleton of our application. This means creating the main Java classes that will form the core of our service.
And here's the project structure we're aiming for. You can see the main application class right there, along with the files for our user entity, repository, and eventually a service and controller. For today, though, we're just focusing on demo application, user, and user repository.
The first, and honestly the most important class, is our main application class. This is the entry point that will launch our entire Spring Boot application.
The code itself is remarkably simple, and that's because all the magic is happening in that @Spring Boot application annotation. That one line tells Spring to handle all the heavy lifting, component scanning, auto configuration, even starting up an embedded web server for us. The key takeaway here is that with just this tiny class, we have a fully runnable application. It's pretty amazing. Next up, every useful application needs to manage data. So let's create the data layer, which is going to consist of an entity class to represent our data and a repository to talk to the database.
We'll start with the user entity. This is just a simple Java class, what we call a POJO, that is going to map directly to a users table in our database.
Now, if you look at the code, you can see how this works. The @entity annotation tells Spring Data JPA, hey, this class maps to a database table. We use @ID and @generated_valued to set up our ID field as the auto-incrementing primary key. And notice the @data and @noargs constructor annotations? That's Lombok at work, saving us from having to write all that tedious boilerplate by generating our getters, setters, and constructors automatically. It's a lifesaver.
Okay, so now that we have a user entity, we need a way to actually perform operations on it, like creating, reading, updating, and deleting users. This is where the repository comes in. And this is where the power of Spring Data JPA really shines. All we have to do is create an interface, user repository, and make it extend JP repository. By doing just that, Spring automatically gives us a whole set of CRUD methods right out of the box. We don't have to write a single line of implementation code. It's just incredibly efficient.
And just like that, we're done with the foundation. In a really short amount of time, we've set up a fully functional Spring Boot application with a working data layer, all based on sound architectural principles. This is the application we'll be testing for the rest of this series.
So, we have a foundation that can store data, but an application isn't very useful until it can actually do something with that data, right? So what's the next logical step to add some business logic?
In Part 2, we will add the business logic and verify our APIs. We'll build out the service and controller layers, expose our endpoints, and get everything ready for our very first BDD tests.
For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.